All right, everybody, today, this video is for Tuesday, February 9th. If you don't have your math notebook and pencil nearby, you want to go ahead and grab that. Remember, you can push pause during the video at any time. So your requirements for today are to watch this video and open up the student paced Nearpod that is posted on the doc for when you are absent, as well as to complete the equivalent fractions iReady lessons. So on Monday, we looked at this problem here, and it says Raul needs half a stick of butter to make cupcakes. He needs 1/4 a stick of butter to make the icing, and we need to know what fraction of a stick of butter does Raul need in all. There were two answers that I saw the most of. So we're going to take a look at both of those and discuss what's going on. So here in this problem, you can see that this student did 1/2 plus 1/4, and they got an answer of 2/6. So it looks like this student did the numerators plus each other and got 2, and did the denominators plus each other and got 6. So let's look below at this model to see what's actually happening and if this is a correct way of thinking. So this piece right here, the one hole, represents an entire stick of butter before it was cut. Entire stick of butter. So this white piece, because it says half a stick is for the cupcake batter, so you can see they cut half a stick of butter, and they use that for the batter. Then they went back and they cut a quarter. A quarter is another way that you can say 1/4, a stick of butter to make the icing. So this represents right here what was used. What was used to make the cupcakes? What was used to make the cupcakes and the icing? And then you can see, again, when this student got their answer, they said the answer was 2/6. Well, I represented what 2/6 would look like compared to using half a stick of butter and a quarter compared to the whole entire stick of butter. And guys, take a look. Is it reasonable to start with a half a stick, use 1/4 a stick of butter more, and then get an answer that says that we only used this much? So again, if you're thinking about it, 2/6 is actually smaller than a half. So 1/2 is greater than 2/6. So is it reasonable if I cut off a half a stick of butter and then get an answer that's smaller than the half that I cut off? And the answer to that is no. So this example shows that the students who got an answer of 2/6 need to grow their thinking a little bit more. So let's take a look at what this should look like. So here you can see we have the exact same problem, but now the student is saying that the answer is 3/4 a stick of butter. Let's talk about how they got that answer. Well, you'll notice that once again, this first part is the same where they're talking about the whole, talks about an entire stick of butter. Again, you can see, well, here is for the cupcake batter, and here's for the icing. But now you'll notice that along the bottom, we're showing the answer of 3/4. Well, one of the things that you're going to see that's different than before is that, well, they both show the same amount, meaning they both start and end here. So you can see, well, wait a second, before when the 2/6 was not even equal to the half, here our answer matches up exactly to adding 1/2 and 1/4. So let's look at exactly what's going on. Well, one of the things that you're going to notice is, well, wait a second here, the half is equal to 1/4 piece and another 1/4 piece. So in this problem, what we did was we just rewrote the half using different size pieces. As we talked about yesterday, 1/2, I can shade it in if we're looking like our models from yesterday in our notes, is equal to, well, if I cut my circle into fourths, 4 equal pieces, I would have to shade in 2/4, which is what's being shown right here. 1/2 is equivalent or equal to 2/4. So in order to add this problem and get the answer of 3/4, what we actually had to do was trade in the 1/2 for something that's the same value. So instead of doing 1/2 plus 1/4, we had to trade in that 1/2 for 2/4, because now we have the same size pieces. And we can figure out, we used 3 1/4 pieces, or 3/4. Again, let's take a look at this. So we started with half a stick of butter and we added 1/4. When you look at this, I can't get an answer because I don't have the same size pieces. I have different denominators. But what I can do is turn them into the same size pieces using equivalent fractions. So again, you can see, wait a second, 1/4 is the same as another 1/4 makes a 1/2. And when I put them right on top, you can see, that represents the half of butter. And here is my answer of 3/4. So let's take a look at some important information. So here are the rules when adding. Before adding fractions, the fractions must have the same size parts. So again, here, because we have different denominators, which represents right here, you can see different size parts. And that's very easy to see. You can see that the white block is bigger than the yellow block. So now let's take a look at what we need to do. It says you can use what you know about multiples, which we're going to look at a little bit more on the next slide, and equivalent fractions to find a common denominator. Well, common denominator means same size parts. So here you can see now we have the same size parts. And that is exactly what common denominators talk about. We are turning our fractions, when we go to add them, into the same size parts using equivalent fractions. So again, now you can see that 1/2 is really 2/4 plus the 1/4, and that equals 3/4. So this was our try it problem from yesterday, where I didn't teach you anything about adding with unlike denominators, and we were just trying to look at the connections you could make. Now that we talked about some of the really important pieces that are involved when adding fractions with unlike denominators, let's take a look at our learning targets and another example. All right, so in this new lesson, we are going to be focusing on the following 3 learning targets. When given 2 fractions with unlike denominators, we're trying to find equivalent fractions using common denominators. In the next one, it says use models to represent adding and subtracting fractions. Right now, we're only going to focus on adding in this unit with unlike denominators. And finally, the last piece of this, it says use equivalent fractions to add fractions and mixed numbers, which was a term we went over in class yesterday, with unlike denominators. So again, you can see a couple words really coming up a lot. Unlike denominators, equivalent fractions, adding, subtracting. So let's take a look at exactly how we can take our learning objectives and put them into action. So before we begin this problem, if you don't already have the student-paced Nearpod open, you're going to want to open that so you can write in the Nearpod as the video is explaining this problem. So again, push pause on the video as much as you need to, but go ahead and open up the student-paced Nearpod, and you can find that link right on the dock next to where you opened up this video. So the problem says, Kim walked 1/3 miles to her friend's house. Then she walked 3/6 of a mile more to the park. What fraction of a mile did Kim walk in all? So we know this problem's about Kim. She's doing some walking. First, she walked to her friend's house. Then she walked 3/6 more to the park. And we need to figure out how far she walked in all. So now let's pull out those math numbers that are really important. Kim walked 1/3 of a mile to her friend's house. So you can picture if she's starting here, she's going to walk some amount to her friend's house, and then she's going to keep going, and she's going to walk 3/6 more of a mile to the park. And our goal is to try and figure out how far did Kim walk in all. So again, you can see that this represents to her friend's house, and then this would represent how much further she walked to get to the park. And we want to know, well, Kim, you were out walking. How far did you go? So right now, when you see this problem, you're thinking to yourself, okay, I need to do 1/3 plus 3/6. Well, taking a look right now, do we have the same size pieces or different size pieces? I have thirds and I have sixths. If you're thinking to yourself that they are different, you're correct. Let's take a look at what that would be with fraction strips. So it says that she walked 1/3 and then she walked 3/6. So again, you can see that this is showing that these are not the same size. The blue piece is not the same size as one of the green pieces, which tells us that we cannot add these. Remember, if they don't have the same denominator, we don't have the same size pieces, we cannot add. So let's go ahead and read. It says, first, we need to make both fractions have the same denominator. All right, so we need both fractions to have the same denominator. We're going to figure out what that denominator should be by using multiples that they both share. Multiples is just another way of skip counting. So we are going to go ahead and skip count by our denominator of 3 and 6 and find a number that's on both lists. So let's take a look, all right? We're going to start off with 3. A little bit more makes 6, 9, 12. Here we have 6, 12, 18, 24. If you haven't already written this in your own Nearpod, again, push pause on the video, write this in your student-paced Nearpod so that way you can do this as well. Splitting your screen is a really great way where you can watch the video on one side of your screen while you interact with your Nearpod on the other. So It says we need to find a number that they both share, a number that's on both lists, because that's going to tell us what our same denominator or common denominator will be. So let's take a look. Well, go ahead and circle the numbers that appear on the top for your multiples of 3 and on the bottom for your multiples of 6. Did you circle the 6 and the 12? If you did, great job. 6 and 12 appears in both lists, which means that either of those numbers could be used as our same denominator or common denominator. But the trick is that you always want to use the smallest one. This will save some steps at the end. So we're going to go ahead and use the 6 as our common denominator. So what that means, guys, is that we need to take our problem, and our problem now, instead of it being 1/3 plus 3/6, it's going to be some amount of 6 plus some amount of 6. So you can see now we're using the same size pieces. We're using 6. Well, one of the things that is nice is that if you guys look, our second fraction, 3/6, already has the denominator of 6. So that one can stay the same. But we need to figure out an equivalent fraction for 1/3. So we're going to use these shapes down below to help us model. So I have thirds and sixths. You can see the circle on the left shows thirds, and the circle on the left, or excuse me, on the right is broken up into 6 equal pieces. So I'm trying to figure out, well, 1/3 is equivalent to how many sixths? And that's going to tell us what our new numerator is. That's going to go right there. Okay? Let me go ahead and erase that. So I don't want you thinking that's a 0. That's just the blank spot that we're trying to fill in. So let's do some shading for our model to help us discover what fraction is equivalent to 1/3. All right, so in your own Nearpod, go ahead and shade in this model here to show 1/3. Again, a reminder to push pause so that way you can interact with your Nearpod, and then just come back and push play when you're ready. Hopefully, you shaded in 1 out of the 3 pieces, so it should look like this. You can see I have 1/3 represented. Well, now we want to shade in the same amount on our other circle. So even though it's broken into 6, I can still represent this same amount of shading over here. So again, go to your own Nearpod and try and shade in a piece of this circle that represents the same amount of blue that I colored over here. Hopefully you realize that you could shade in this amount just like that. So now you can see you found your new numerator. 1/3 is the same as 2/6. So when I go up here, you guys can see that my new problem, instead of doing 1/3 plus 3/6, is now 2/6, because they are the same, they're equivalent. And now I can get my answer of 5/6 of a mile. Let's see what this looks like with fraction blocks to check. So we already have our problem set up of 1/3 plus 3/6. We know that we're going to change them all to having pieces that are the size of 6 because we found that common denominator by listing our multiples here. So now I'm just going to replace the 1/3 with 6 and take a look. Well, 1/6, 2 1/6 pieces is equivalent or can represent the 1/3. So when I put them all together, you guys can see 1, 2, 3, 4, 5 1/6 pieces, which matches our answer. Your denominator always stays the same because that represents the size of the pieces. The numerators are what we add because that says how many of those pieces we have all together. So now your responsibility is to go ahead and try this problem independently. Make sure you submit your Nearpod when done. And again, you can always attend office hours if you have any questions.